Recording now. Good afternoon or good morning or whatever time it is when you're watching this.
Good day to you.
Good day. We have to figure a lot of things out because
Good night to you, or
it's probably good like 2 a.m. to you because they are.
you should do schoolwork during the day. If you're watching this at 2 a.m., we're in trouble.
Yeah, well, All right, so we're going to combine sections 1.3 and 1.4 because they all deal with linear functions. And we felt like we could do some of this first chapter together.
You probably learned that in 8th grade and then 9th grade and then 10th grade and then the 11th grade. And so
these are, whether it's a function or written as y equals, again, we talked about that last video, how y equals represents the function. So it could be y equals mx plus b or f of x equals mx plus b. There are some things to remember that we're going to try to refresh or hopefully get it into your head. M represents the slope. We'll talk a little bit more deeply about the slope. B will represent the y-intercept, and that's where the graph crosses the vertical axis. There's a couple other couple of special cases when you have what's called the identity function, y equals x, or just the parent function. That's the unmanipulated graph before we start messing with the slope and y-intercept. And then there's two ones that really confused me. I had a hard time with these when I was in high school. Y equals is a horizontal, x equal is vertical. And so there's some ways to try to remember that, but we'll talk about that maybe a little bit later. Okay, so slope. When would we ever use this? Ms. Young, you want to talk about when we would ever?
We added this in here because I thought you guys might wonder, like, why do we keep having to learn about slope? This is ridiculous. And the reason is because a lot of things in life are predictable because of their rate. And if something has a constant rate, an unchanging rate, then we call that linear, right? If something never changes. So there are a lot of instances where things are constant and unchanging. And then there's a lot of instances where they're almost constant and unchanging. And we actually use linear to model that as well.
And we talked about gas mileage on your fuel economy in the previous lesson. And your fuel economy is miles per gallon. Anytime you're trying to find a relation between those two things, if your car drives at 20 miles per gallon all the time, if you drive at a constant rate, it's very predictable how much gas you will need to go a certain distance. And that's, and most cars do that. Now, there might be some minor fluctuations, but generally they stay pretty steady.
Yeah.
Okay. And so a couple things that we want to get us going on this is slope is, there's lots of different ways. You might have heard rise over run, vertical change over horizontal change, or the slant. And the equation for it is y2 minus y1 over x2 minus x1. And I don't know, maybe I'm going to open a can of worms here, except I'm not going to do it without picking up my pen first. Delta y over delta x. There's a little bit of calculus in there, but delta means the difference or subtraction, okay?
So if we were talking miles per gallon, right, then it would be the change in miles over the change in gallons. How far did I travel? How much fuel did I use, or something like that?
Mm-hmm. So that's what, I mean, or any of that kind of stuff, whenever it's something per something, that really is a slope. And that's a predictable relationship. Okay, moving on.
I'm going to figure out that button.
I'm sorry, yeah. Well, I keep forgetting to hit the mouse, changing my annotation to the mouse, and it's drawing, and I'm getting better at it.
So if you think about slope as a rate, right? Then you have seen slope 4 ways. You've seen a positive slope where your line is increasing, and a negative slope where your line is decreasing, and a zero slope where your line is flat, and an undefined slope where it's vertical, right? And so if you think about this in terms of real life, a positive slope would be when something keeps going and the other variables increasing. Take my weight since high school. The years go by, my weight is increased. Not quickly, but it has. Mr. Bobby, what's a negative slope, do you think? What's something that's been decreasing?
It goes on and the other thing falls down. So if I were to exercise more, my blood pressure might decrease, okay?
Yeah.
Yeah, the more positive example, a positive example, as I exercise, the longer exercise, the more my heart rate would increase.
Yeah. Yeah. Although at some point that would actually.
It would actually, and it doesn't always stay, but.
So, and then zero slope, think about things that are unchanging, right? There are things like that I would like to have remained unchanging, like my weight, but things that are unchanging, but the one variable is still continuing to increase. Yeah. And then undefined slope, Mr. Robbie.
Well, that's pretty much what we've been living in the last couple of years, where we can't go anywhere. You're stuck on one X value and you can't change. So that's where I've been the last 3 months. So,
yep.
All right, moving on. There we go. Now let's find some slopes. We use the slope formula, the change in y over the change in x. So quick, this does not matter which one you use first, but I like to start with try to avoid negatives because I'm a very positive person. So I would do 7 first. I would start with the y's and then minus the other y value, which is 3 over. Now, since I started here, I got to start with that point again. I have the choice in the top, but once I choose that in the top, I got to stick with it on the bottom. So I'm going to start with its corresponding x value and then the corresponding y value. I'm sorry, the other corresponding x value. So this would equal 4 over 2, which gives me a slope of 2.
And remember we talked about here that slope is really just how things change. So if I look at my y values and I say, okay, I changed from 3 to 7, that means I changed by 4. And if I look at my x values and I change from 2 to 4, I changed by 2, right? So you have that 4 over 2 ratio coming from that change in y over change in x. I actually rarely write the subtraction part of this because I just look at what's the distance from 3 to 7.
So I'm going to start with that point, but I could have started with the other. And if I had switched it around, I still would have got the same answer. But I'm going to start right here with the 5. And then I got to grab the negative 2, or the 2, minus the 2. But since I started with this point on the top, I got to start with that point on the bottom. And then minus negative 1. How many of you don't mess with the minus negative 1, but that's really what's going on? So what is this, 3 over 5? Okay. I know what I'm doing wrong now. I just got to learn to fix it. So.
Why it's dragging like that?
Yeah.
Okay. Yeah.
Okay, maybe I can fix it in the future, but right now I'm not going to worry about it. So take a second if you want to pause the video and try the one below on part C. Go ahead, pause. Okay, you can come back. Thank you. And I know many of you didn't, but I'm still going to pretend like.
I bet they all did. I think they all did it all by yourselves, didn't you? And you're like, why is this one different?
I'm going to do this point, start here. So I'm going to start with the 3. And so I'm going to do y minus y. So I could minus negative 3. I'm smart enough to say that's plus 1. And then on the bottom, I'm going to do 3 minus 3. Rutro-Warge, I got 4 over 0. And if I put that in the calculator, my calculator curses at me.
Remember, this means unchanging x value. Unchanging x value means you got a vertical line, which we just talked about is an undefined slope.
Okay. I'll tell you what I figured out right now, but okay. So, or later.
Yeah. The kids don't care.
If you get 0 on the bottom, bad. 0 on the top, it's 0. 0 divided by, if I have 0 cookies, that means Miss Young and I each get 0. But if we have 4 cookies and we're not sharing them among anybody, it doesn't make any
ourselves, then that's sad.
Ask Siri to divide by 0. I think they actually took that away. So, have you ever got Siri?
I won't do it. Yeah, I was going to do it, but we won't make it in the video.
They won't make it. Let them figure that out.
Yeah.
Well, moving on. So let's find some slopes in y-intercept. Remember, we talked about, we had a minute ago that the equation was y equals mx plus b. Oops.
M&Ms. Now all of a sudden I want chocolate.
Okay, that's not what I was thinking. So if I just look in this equation, I can just pick out that m is 3, the number in front of the x is my slope. These are super easy, especially when you have the b, though, has got to be -5. Because I really would want that plus in there, but there I'd have to think of that as plus -5.
Yeah.
Now
And if it were negative, if it were negative 3x minus 5, the slope would also be negative. Take the sign with the number, no matter what the sign is.
Now the problem is b and c aren't solved for y. They're not in slope-intercept form. So like, hey, you know what? It's like halfway through the second video and we finally get to do some algebra. So I want to remove 4x from both sides.
Really, he just wants to remove 4x from the left side, and when he removes 4x from the left side, it's going to end up on the right side.
You're correct. Thank you for correct. So I end up with, what if I write it this way?
Well, if you write it that way, Mr. Bobby, it's not an mx plus b form. Remember, we want mx first and then b second.
Okay. You could write it that way and then fix it, or it would have been smart the first time just to do -4x plus 3.
Remember, when you switch it, the signs go with it. So you wouldn't want to write this as 4x minus 3 because then you've changed the sign of the slope and the y-intercept.
In this case, the b is positive. I do take the sign like you said, but the negative comes in there, okay? What about problem C? That's not in slope-intercept form. We get to just do some more algebra. Woohoo! I get to multiply this out.
But Mr. Bobby, what is the thing that tells you that you need to multiply that out?
The parentheses.
The parentheses.
Yeah, multiplication. I'll look at you all trying to be all sophisticated. So
I put on my earrings and everything for y'all.
don't let her lie to you. We recorded these first 2 videos in the same night. It was between the sessions we went and changed our shirts.
I pulled my hair back, changed my earrings, changed my shirt, so you guys would think this wasn't the same night, and he's telling on us.
I ratted her out. She's like, after we finished, she's like, I gotta go change my shirt. I'm like, what? Oh my gosh. Oh, I did get a different pair of shoes though. Here's a different pair of shoes for you too. I even got a different.
We got the sparkles for you.
All right. And finally, I'll bring the 2 over.
So in case you've lost the vein of the math that was just happening, he distributed the 3 into x minus 3. 3 times x is 3x, and 3 times 3 is 9. Notice now that it's still not in y equals mx plus b form. It's y minus 2 equals 3x minus 9. That minus 2 attached to the y, he's just moving it over to the other side of the equation, and he's getting y equals 3x minus 7, making m3 and b -7.
Okay. All right. So basically, if you can get it into this form, it's very easy to identify slope-intercept. That makes it, we're doing that because you're going to be asked to graph a line. And if it's in this form, we're going to be able to graph it very easily. Okay. So.
And there's not an example here, but just in case you ever ran into an example, if there were a number in front of the y in any one of these problems, then your final step would just be divide by that number.
Yeah, I guess I could have made a better example. Quickly.
You make beautiful examples.
And we're going to make a graph here in a second. And many of you perhaps have a feeling that maybe at one point in your mathematical resistance, by the time you're in college algebra, you've done this once. Identify the slope-intercept, we'll plot the y-intercept, and then we'll use the slope, do the rise run to make the graph. I had a teacher who would yell at me if I didn't do 3 points, and I always, would try to like make it harder for her to find a 3rd point, and then it got. Anyway,
so the rule of thumb is in order to make a line, you only ever need 2 points. Now you got me saying crazy stuff.
Do that even in like 9th grade.
9th grade geometry, or whatever year you took geometry, you should have learned that 2 points create a line on any plane.
So for this case, oops, I hit the wrong. I gotta go back.
Yeah, back and then back. 2 backs.
2 backs. Okay, so I want
We have the slide at this point. We don't have the slide before this one?
I thought we just talked about,
I
yeah, this is the equation for the lines. I'm sorry. You want to talk about this, Ms. Young? I'm sorry, my bad.
I just thought you guys might like to be reminded that when you are graphing a line, you're probably, hopefully, going to see it in y equals mx plus b. We just talked about how to find m and b, where m is rise over run and b is where it's crossing that y-axis. But there's another form that you might see, y minus y1 equals m times x minus x1. You may or may not have been introduced to point slope form before in your mathematical career. It's kind of a nice format for when you're writing the equation of a line, which we'll come to in a little bit. But if you are asked to graph in a situation like this, we have a couple options that we're going to talk about. So now would be a great time to jot down in your notes y equals mx plus b form, also known as slope-intercept form, and y minus y1 equals m times x minus x1, also known as point-slope form.
We'll talk about how we will use this to graph a line without having to do all the algebra.
Right.
Or in an example or two. So for this first, these are two ones that are in slope-intercept form. The intercept for problem A, and I was trying to jump the gun a moment ago. This is the y-intercept, -1. So I would go down to the point -1 on my x-axis or my y-axis. And then I would have to do the slope, which means I would rise. So this slope, my m, I want to think of it as 2 over 1. So I'm going to go up 2 points and over 1 and put a dot right there.
It's super important to think about the fact that the top of the fraction is change in y. That's the rise part, right? Just like the y-axis goes up and down, your change in y goes up or down. And then your change in x, which is the denominator, going left and right, like your x-axis.
And to make Miss Fott happy, I would have had to do a third point, but I would have done it like up here just to annoy her or something. That good. Don't do that to me because I'm cool. Don't do that to me, but you can do it to Miss. My teacher's name was Miss Fott, so. And then I want to connect those dots. Now my problem is I'm a terrible drawer of lines. If you have your OCD, you can get your ruler. My wife is gloriously intelligent and wonderfully beautiful. And the way she draws a line is she starts from one point and goes down, and then goes from the other point and goes up.
That's how I draw.
You know, I told you were the second most intelligent woman I know.
You just switched screens, yeah.
I did because I got off my mouse. There we go. No, this is the right one. Okay.
Yeah.
Got off my job.
If you are using your calculator to graph this, then make sure that you're really paying attention to where the points are. Because when we grade this in a test or quiz situation, we are going to pay more attention to the points that are graphed than the actual line that you draw.
Right. I'm going to pay attention to the fact that I'm looking for you to stop going backwards on me. I'm looking for you to have this y-intercept correct. All right. So I know that y-intercept has to be here at +6. Okay. And -1/4 means I got to go down 1 and right 4. Now I could have gone left 4 and up 1, but I ran out of room. So
just want to make sure that because your slope is negative, that your overall line is decreasing.
And some people like to do this, draw their little triangle in there, or do it with dots and stuff. I'm not doing that because I don't want to confuse you. That's not really part of the graph, but some people use that to make them. Okay. Yeah. So let's talk about those other examples and actually move on to the next page when I mean to move on to the next page.
Smart, yeah.
And clear all the ink. And you, by the way, we're in the middle of the screen, like where your icons are right now. So if we look at problem C, I like to think about it this way. I could solve this for y, and that's a whole lot of algebra, and I'm probably likely to mess it up. So if I plug 0 in, 0 is my favorite number to do math with. So if I put 0,
I'm gonna stop you just a second there for Mr. Bobby. For Mr. Bobby? No, for me. this is form that you're seeing right now, 3x plus 6y equals 18. We haven't introduced it to you. It's called standard form. So he's specifically telling you a method right now that's based on an equation written in the form ax plus by equals c, where first you have the x, then you have the y, then you have an equal sign, and then you have a number. So this is a method for a very specific type of equation that you're given.
And there's no multiple other terms, no parentheses, it's just X, Y, and the number. The reason I'm bringing this out, the only reason I brought this in is because I see this on the ACT a fair amount. Do you agree with that?
Yeah, I do. Yeah, they like this form.
They like this form, you may see it. So the short way to do this is to imagine like taking away each X value or the X value or the Y value. And I can do that because it's basically I'm plugging 0 in. If I put 0 in for X, this first term is gone for the time being, right? So if X were 0, that means it's going to be somewhere on the Y up and down. I haven't moved, so I would be like right here, but I'm not because I have to solve that equation for Y. So what I'm going to do is, can I solve that equation in my head? Do I need to actually do algebra now?
I mean, I think we could say like 6 times what number is 18?
Ooh, we're high school students. We don't, and yeah, you know that's 3, right?
Yeah, of course, yeah.
0, 3. You're smart folks. You're intelligent human beings who know your multiplication factor.
So what he's just done, just in case you got a little lost in all of that, is he has plugged 0 in for the X value, and that means that 0 plus 6 times 3 has to be 18. He's quickly found the y-intercept by plugging 0 in for X.
And this is going to be one of the times where Zoom will let us down. I'm literally putting my finger over it on the computer screen.
You could imagine like on the 3X.
Yeah. Put that over 3X. Now you can the ceiling. Okay. Now, if I did that with the 3X, I can also do that with the Y. So I'm going to erase my imagining, and I'm going to change colors so you can kind of see it. So I can do this really quickly. I just can't do it really quickly in Zoom. Why are you not staying green? Draw. Okay. So if I were to cross out the Y value, that means I'm not moving up or down. I'm just somewhere along the x-axis. And this is kind of how I actually made sense of the vertical and horizontal lines. I'm not moving up or down. I'm finding where I'm going to be along the x-axis. So 3x equals 18. If I imagine or if I cover up the 6y, again, this is an equation that I can easily solve. X is equal to 6. So x is 6, y is 0. And how many points do I need?
Just 2. And if you're taking notes at this point, what he just did is he plugged 0 in for y and found the x-intercept.
We don't talk about the x-intercept very often, but it's a nice way of doing this very quickly. And if you practice that technique, you can solve that ACT question in a matter of seconds.
Yep.
Okay. All right. This is problem D is Miss. I'll let Miss Young do D.
Can I annotate? I don't know that I can. Let's see.
I don't know. You can try.
I can.
Okay.
So we just talked a minute ago. I have to use my mouse pad, so I'm not going to be as smooth as him. About point slope form, which is y minus y1 is equal to m times x minus x1. And the thing that's so nice about this is we could absolutely distribute and add 3, get to y equals mx plus b that way. But also in this form, we're kind of quickly told here that m has to be -2. So now I have a slope and I have an x value. Now this is tricky because it's actually the opposite of the x value. So my point here is going to be -4 and not +4. And you're going to see this a lot in this class, where if the formula has minus a variable, you actually have to change the sign. So in this case, it says -3, but we want to pull +3 off. And so now I have a point and I have a slope. Kind of a weird way to look at this, but it's super nice because I can just plot the point -1, 2, 3, 4, and up 1, 2, 3. I hope I made it. And then I can count off my slope of -2 and remember that You have to have a change in y over change in x. So if you don't see a change in x, it's 1. So I would have -2, 1, and I could, from there, draw my line. And I drew a short little line.
Well, you know, short lines are people too. So, I mean, they'll throw that on the ACT too, and you can do it really quickly by recognizing the point that's there without having to solve and do all the algebra.
Absolutely. And again, either one of these equations, we could have easily solved for y to get y equals mx plus b. We're just showing you an alternate method that you could use that's faster.
Okay. So, so now we're going to get to writing the equations and lines. And again, this is a big deal, especially if you're going on. Basically, we're going to plug in. Now we have something graphical. We're trying to get the equation versus having an equation trying to get the graph. So if I have the a point and a slope, I can use that point slope form that Miss Young was talking about. So it's going to be y minus -3 or -3. And then I'm going to use the slope, which in this case is 1/2. And then x, I'm going to write it out as -4, at least for now, because maybe you didn't do a lot with this. Okay. Now, is that enough? Can I, oh, you're trying to annotate with me. This is fun.
I was just helping people understand that you just plugged in x1 and y1 into the formula.
Okay. Now, if the instructions tell you, or if it's a multiple choice problem or whatever, if the problem says solve it for, or give your answer in slope intercept form, what would I have to do right now?
Well, the first thing I personally would do is deal with the fact that you have a parentheses and a parentheses with a minus negative situation right here.
Right, and that would be x -4. So I would have, I would have to do y -3. Can I do 2 steps in one, or should I?
No, just go ahead and just change it to x plus 4 and then distribute the 1/2.
Okay.
It'll be good for notes.
Yeah. Okay, and then y -3, I'd have to distribute the 1/2 at this point. -1/2 times 2 is, now somebody check -2. Check my signs here and all that.
Yes, and he meant 4. That's what he did.
Yeah, that's what I did. And then I have to add 3. This is fraught with error in my case, because I occasionally make mistakes, but when I do, it's
Yeah. So in the last slide, when we were saying we could easily take the form to y equals mx plus b, this is the method you'd use.
But if they don't, unless the directions specifically tell you, and they might ask you to do it in point slope form, but so. Now what about problem B? What don't we know about problem B?
So we always need 2 things to write the equation of a line. We need a slope and we need a point, right? Like we had in example A. And sometimes we're given even more specific information, like sometimes we're given y-intercept, and that's amazing. But we always have to have a slope. And so what we're going to have to do in this problem is find the slope, y minus y1 over x minus x, or excuse me, y1 minus y2, or y2 minus y1, because the order doesn't really matter, over that same order in the bottom with the x's.
Wait a second. What the heck was I thinking? 13/6. Okay.
So now we're going to have some really pretty fractions in this problem for you guys. And you're going to see my husband walk by.
So which point do you want to use? Do you have a preference? At this point, you have 2 points and you have to find, I had to find the slope first, and then I could choose my point. I would look for when I'm deciding which point I want to use, -3,5 or 3, -8. First thing I do is look, is there one I can get away with smaller numbers or no negatives? I can't really do that here, so it doesn't matter. So I'm going to use the first point just for kicks and giggles. So it'll be y -5 equals -13/6 x plus 3.
Yeah. And remember, look at the directions. If it just says write the equation of a line, guys, stop. Don't go further. If the directions say write the equation of a line in slope-intercept form, then you have to go all the way down to y equals mx plus b. But guess what? It doesn't. All it says is write the equation of a line. Guess what this is? This is the equation of a line in point slope form. Stop. You're done.
Yep. I didn't specify the form, so you're good to go. All right. We need to clear the writing. So the other thing that comes up a lot is, and you might have seen some about parallel and perpendicular in geometry. I hope you did. Parallel lines are two lines that are in the same plane that never cross, like railroad tracks or the yellow lines down the middle of the road, unless the driver or unless the line painting guy had, a little.
Yeah.
And perpendicular lines are two lines that intersect at a 90-degree angle, like your ceiling and your wall or your floor and your wall. And so,
unless you have one of those houses, that's like,
yeah.
anyway.
Yeah, that's true. I did have a nice house that had weird angles in it once. Parallel lines have the same slope. So if they are, if all you got to do is same slant, they're never going to cross. And that actually really does make sense. Parallel means they never cross. Slope is the measure of the slantness. If they're slanted the same way, they ain't going to cross.
So think about it like this, like if we think about slope as a rate and we're telling you that they have the same rate, it would be like Mr. Bobby and I are going to make the same amount of money, but he's going to start with $500 and I'm going to start with $0. We're never going to have the same amount of money because we started at a different place, but we're growing at the same rate.
So to find the slope of this line, I just need to do what we did earlier. When we didn't have the problem solved for, we couldn't find the slope, we have to solve for y. So I have negative for y equals, and I'll make sure I'm being good here, negative 3x. That's supposed to be a negative there. Making it worse. And it's plus 4, right?
Negative 3x plus 4. Yep, because 4
I
is.
don't really care about this number on the end here anymore, but I do want to divide everything by negative 4. And then that's probably going to drive Miss Young crazy that I did that. But I'm going to get y. What's negative 3 divided by negative 4? It's positive 3/4.
So this giant line underneath this whole equation right here, which is bad math, by the way, is him dividing all three pieces in this equation by negative 4. So in his head right now, he's doing negative 4 divided by negative 4 is 1. Negative 3 divided by negative 4 is 3/4. And 4 divided by negative 4 is negative 1. That's where all those numbers just came from.
All right, all right. Yeah, I would get kicked out of the math teachers club by doing it that way. But I would imagine I could actually imagine,
Yeah, you can do that.
You can probably do some of that in your head, okay? Yeah. Everything divided by negative 4, especially because I had 2 4s in there, okay? And I knew the first one's, my purpose is to get the y by its lonesome, okay?
I do think like it's important for us to stop for just a second though, because up here you have parallel lines have the same slope, and do they have the same slope?
Yes.
Their slopes are 3/4, and different y-intercepts. Do they have different y-intercepts? Yes, they do. If they have the same y-intercept, they're not parallel lines, they're the same line, okay? The exact same line.
Dang it, you just took away one of my test questions. I was going to ask that as a test question.
Sorry.
Oh man, now when I ask it, then maybe they'll get it right.
Yeah, still ask it. We'll see if they watch the video.
Yeah, that'd be good. So what about the second example for perpendicular? Well, this one's easier to solve. I just have to subtract 3x from both sides. And when I do that, I get y is equal to negative 3 plus 7, 3x plus 7. Now, I don't have to worry about their y-intercepts to do perpendicular. I just need to take the slopes of the two lines, multiply them, and see if that results in a negative 1. So is 1/3 times negative 3 equal to negative 1?
Well, I think it is.
I think it is as well.
You might have been told in a previous math class that perpendicular slopes are opposite reciprocals or negative reciprocals. And that's true, they are that. The actual math definition of perpendicular, though, is that when you multiply them, the product of the slopes is -1.
And it is the same, because I could write -3 as -3/1. So it is the reciprocal and negative. That's just kind of a more casual way, you know.
Yep.
Okay. I think we have one where you actually have to find the equation of line that's perpendicular or parallel.
Let's do it.
Do it, and let's clear all this junk off here. Okay, so again, I'm gonna have to move Miss Young's big head out of the way.
I could shrink it.
Well, it's not your head, it's your window.
Okay.
So we have an equation, write the equation line parallel to.
Mr. Bobby, I think this would be a good time for the kids to hit pause
And try it?
see if they can try this problem on their own.
Okay, pause.
Pause. Okay, we're back.
Maybe you're not, well, that technique's probably gonna get played out, but whatever. This is gonna be, oh, no, you can do the homework, and I can maybe go back and get my pen. Go back and get my pen. When I solve this equation, I'm going to get -5y equals -4x plus 23. And I think you're thinking, what the heck was with this 23? Come on. And when I divide everything by 5, I'm going to get -5. I'm going to get y equals 4/5, because a negative divided by a negative is positive, plus 23/5.
How about plus -23/5 or minus 23/5?
I don't really care. How about that?
Well,
I don't really care about this problem.
because you don't care about the y-intercept. You only want the slope off that line.
All I care about is the slope of that line.
Yeah, absolutely.
Yeah, that's there to like mess you up. I don't want to mess. I don't care. I care about 4 or 5. That's my slope. Okay, and then this problem is essentially the problem we did a few ago, where I have a slope, and now my slope is 4/5, and I'm gonna use this point. You never need to worry about the slope of the original given line. So I'm gonna do.
Remember, different y-intercept. Different y-intercept.
I'm pretty sure it's not 23 -5ths or whatever it is. And so this would be 4/5 was the slope that I got.
Yep.
And x minus 10.
Yep. So he's just plugging it into y minus y1 equals m times x minus x1 right now. And guess what he's doing? He's stopping. You know why he's stopping? Because it does not say write your equation or write your line in y-intercept form, slope y-intercept form. All it says is write the equation of a line. So once you get it plugged in, stop.
What would change if we were doing perpendicular? The only thing that would change in this problem is I would need a number that I multiply 4/5 by to get -1, and that's where that opposite reciprocal comes in. So I would do -5/4 and do x minus 10. They like these problems on, a lot of algebra teachers like these problems, a lot of ACT problems, because there's a lot of distraction and a lot of easy places to mess you up, but don't fall for it. It's this equation over here has nothing to do with the problem except give me the slope. So look at that problem, get the slope, and decide, do you need the slope the same of that line or the perpendicular or the opposite reciprocal of it? And then use the given point and you're done. Okay, it's just like the others. So I think we're done. I already showed you the homework at one point earlier because I keep clicking the wrong thing. We'll get better or maybe not, but you'll.
I feel like I want to buy like maracas or something. When we get to like this point where it's like, now go practice.
Okay. So this is all in your timeline.
Came in. I just got coffee in the mail. I can use my coffee as maracas.
Oh my gosh, you are ridiculous. I'm going to stop the share right now and let you look at my motorcycle one more time. No, okay. Anyway, thank you for that. We hope you have a good evening. And she's ridiculous.
So good. Bye, you guys. I'll see you for the next one.
All right. So we have to.
Recording. You're still recording.
Oh, yes.